We've talked about solutions, so now we're going to be talking about something that applies to our solutions, and it's called concentration and solubility. So first off, the concentration of a solution has to do with the measure of amount of solute that is dissolved in the solvent. So how much solute do we have in the solvent that we've dissolved it in? That's going to tell you how concentrated something is. You may have heard the term concentration if you're talking about how concentrated, I don't know, like orange juice is. They talk about orange juice concentrate. The more pulp and stuff that is in orange juice compared to the liquid that it is in, it means that it's more concentrated. So uh, if we have salt water, the more salt we put into a glass of water, the more concentrated that solution is. If you have a diluted solution, if you dilute something, that means that you are making it so it has less concentration. So that means you have less solute per amount of solvent that you have. So if you have 1 cup of water and you put 10 grams of salt in it, and then you have another cup of water, same size, and you put 1 gram of salt in it, that 1 gram of salt is going to have a lower concentration, so it's more diluted. So to calculate concentration, we're going to be doing some practice with this in a lab with this. You just have to take grams of solute divided milliliters of solvent. So you will be labeling that with units as grams per milliliter. Secondly, we have solubility. Solubility of a solute is the ability of the solute to dissolve in the solvent at a certain temperature. So we talked about with the solutions presentation, we talked about being soluble. So the solubility is its ability to dissolve, basically, and depending on what solute and solvent you're looking at. So a couple things about solubility is that a gas becomes less soluble in liquids as the temperature is raised. So we talked about a gas in liquid solution. One example is soda. So if you raise that temperature, the carbon dioxide inside of a soda is not going to be soluble, so it's not going to dissolve as well in there. So if you've ever noticed, if you keep a soda out and it gets hot, you start to, especially, I mean, even if you have the cap on like an unopened bottle or unopened can, you still kind of, it's more flat than if you keep it in the fridge, because now those bubbles aren't evenly as distributed as they were before, because at the higher temperature it's not dissolving quite as well. The opposite is true when it comes to solids. So solids dissolve faster with a higher temperature in a liquid. Also, they dissolve faster if you mix the solution, and they also dissolve faster if you crush whatever solute there is. So if you were trying to make a mixture and you put it on a hot plate, it's going to dissolve faster. If you were trying to get it dissolved, like a lot of times with like salt water or Kool-Aid or sugar water, we stir it. Well, it's because mixing it is making it dissolve faster. Also, if you crush up the solute, that's why we have, with Kool-Aid, you've got a powder to put in that dissolves really quickly. If you just had a tablet that was made of the same sugar that Kool-Aid is, it would dissolve a lot less quickly, because it would take longer for it to be exposed to that water. So if you crush up the solute, it makes it dissolve faster. So just know the patterns here with solubility and what the definition of solubility is. For extra credit for this one, how about you go ahead and I want you to just circle the title solubility on your notes page. So the title for this section, solubility, circle it. I'll keep an eye out for it, and then I'll know that you were listening to this video.